Hi everyone, my name is Gopal. Today I am giving a presentation about depletion type MOSFET. Let us see the construction. So if you see the channel depletion type MOSFET, then the channel is made up of n-type material and the substrate is made up of p-type material, and through the metallic contact the drain and source terminals are connected to the n channel, and similarly the gate terminal is also connected through this metallic contact. But if you observe here, there is no direct connection between the n channel and this gate terminal, and the gate terminal is isolated from the channel using SiO2 layer. So if you see the structure of MOSFET, then it is consist of metallic contacts for the drain, gate and source terminals, then the insulating layer and the conducting channel, which is made up of semiconductor material, and that is why this MOSFET is known as metal oxide semiconductor field effect transistor. Now, due to this insulating layer, there will not any flow of current through this gate terminal, or we can say that the input impedance of the gate terminal is very high. Due to this, MOSFETs are used in the application where the minimum power requirement. Let's move on to the working of the depletion type MOSFET. So initially, let us assume that the gate and the source terminals are connected together, and together they are connected to the ground terminal. That means initially let us assume that the VGS is equal to 0 volts and the positive voltage is applied between this drain and the source terminal. So as soon as we apply positive voltage, then the electrons in the n channel will get attracted towards this positive terminal. So if you observe from the source terminal, the electrons starts moving towards the drain terminal, and in this way the current will establish in the n channel. And if you keep on increasing the voltage between this drain and the source terminal, then the current which is flowing through the channel will increase, and this process will continue until all the electrons in the n channel will contribute in the flow of current. And then after, if you increase the voltage, then the current which is flowing through the channel will become constant. So if you see the direction of the conventional current, then it will flow from the drain terminal towards the source terminals, and for the VGS is equal to 0 volts. If you see the output or the drain characteristics, then it will look like this. That means as we keep on increasing the value of voltage VDS, then the drain current ID will also increases, and after certain value of voltage the drain current ID will become constant, and the value of saturation current for VGS is equal to 0 is known as IDSS. Now let's see what happens when the voltage VGS is negative. So negative voltage at the gate terminal will push the electrons towards the substrate, and at the same time the holes in the p substrate will also get attracted towards these electrons. So in short, due to this negative voltage at the gate terminal, the electrons in the channel will get recombined with the holes, and the rate of the recombination depends on the applied negative voltage. So as we increasing the negative voltage, then the rate of recombination will increases, and that will reduces the number of free electrons which is available in this n channel, and effectively it reduces the flow of current. So as you can see from the graph, VGS will become more and more negative, then the value of drain current will reduces, and at the one value of voltage the drain current will become 0. So this voltage VGS is known as pinch off voltage. Let us see what happens when we apply the positive voltage. So whenever you apply the positive voltage at this gate terminal, then the electrons which are minority carriers in the p-type substrate will also get attracted towards this n channel, and due to the number of free electrons in the n channel will increases. So effectively we can say that the flow of current in the n channel will increases. So for the positive value of the voltage VGS, the drain current ID will be even more than this IDSS. Thank you.